Okay, if we want to apply now a combination of transformations, we do exactly the same thing, except, yeah, just apply to the point xy and just see what the total combination of transformations are. So again, let's start with the point x dash y dash. It will become what? Let's have a look. A dilation of a factor of 4 from the x. So if we move up from the x-axis, the y value gets affected. So it's going to be 4y. A reflection in the x-axis. So in the x-axis is a reflection about this way, which means, again, my y value gets affected. So we get a negative 4y, and that's it. So nothing happens to my x value. So from this, we get x dashed is equal to x, y dashed is equal to negative 4y. But again, my equation, I need x equals, and y will equal y dashed on negative 4. So now we can apply that to any equation. The equation I've been asked to apply it to is y equals 1 on x squared, which means y is now y dashed on negative 4, and x is the same as x dash squared. So all that means is I get y dashed on negative 4 equals 1 on x squared. Y dash is equal to negative 4 over x squared. So again, the little dash that I put there is completely, in fact, even from here in reality, I'd be happy enough for there to be no dashes present, because all we're saying is that that's my new equation. All right. Example 2. The point x dash y dashed is equal to 4 from the x-axis, which is again shifting up. The y value gets affected by 4 times the amount. A translation of 2 units in the negative direction of the x-axis. So if we come to the dot, negative direction of the x-axis is back to the left. So the x value has 2 subtracted from it, and 3 units in the positive direction of the y, which means my y value has 3 added to it. So that's what's happening to my point x dash y dash, yeah? Which means what? Which means that x dash is equal to x minus 2, y dashed is equal to 4y plus 3. So again, rearrange, x is equal to x dash plus 2, the y coordinate is equal to y dash minus 3 over 4. So again, we substitute that into whichever equation we're referring to, and again it's still y equals 1 over 4 x squared. So all I'm looking to do is put in my y value is now y dashed minus 3 over 4, because that's what y is equal to. X is equal to x dash plus 2. So we're just substituting that in. Yeah. So now if I multiply by 4, so the y dash is optional, equals, multiply by the 4 across, and then we add 3, y is equal to 4 over x plus 2 squared plus 3. And from our previous knowledge, I know that a plus 2 inside means I move it to the left 2 units, which is what we have, and the 3 on the outside is up 3 units, which is what we've got. So I'm confident we're on the right track there. Final question. It reads exactly the same almost as the previous example, but the order's slightly different. So let's leave it there. X dash y dashed is equal to a translation of 2 units in the negative direction of the x. So we know the x value is subtracting 2. 3 units in the positive direction of the y-axis, then a dilation by a factor of 4 from the x-axis. So from the x is again moving upwards, so y value is affected. So that dilation is applying to everything, is applying to the whole y value. And at this point in time, the y value is y plus 3, so the whole thing gets multiplied by a factor of 4. So that leads me to being x dashed is equal to x minus 2, y dashed is equal to, well, we can write 4y plus 12. So that means that we get x is equal to x dash plus 2, and I get y dash minus 12 over 4 is equal to y. So again, into whichever equation we're referring to, and y equals 1 on x squared. So what is y and what is x? The y is equal to y dash minus 12 on 4, 1 on x squared. Yeah. So now multiply the 4 across. I'll come up here and get y minus 12 is equal to 4 over x plus 2 squared. Then take the 12 over. So you see the big difference between this answer and the previous answer is I'm up 12 units. Yeah? And that's only because I was up 3 units and then every y value got multiplied by a factor of 4, which took it up to 12 units. All right, so let's have a look at 7C now.